Seeing in the Third Dimension by Lisa S. Torrey. Most likely you've watched a movie while wearing a geeky looking pair of glasses that made an alien creature leap out of the flat two-dimensional screen and grab you with its slimy green claws. Of course, the alien creature didn't really enter your three-dimensional world, but that's a pretty cool visual effect. And I'll bet you either screamed or jumped out of your chair. Those geeky looking glasses, known as 3D glasses, helped create the illusion of a third dimension. Most movies are two-dimensional. The images have height and width, but not depth, so they appear flat. In order to make a movie resemble the real three-dimensional world, filmmakers rely on an optical illusion. It fools the eyes into seeing depth where there is only a flat screen. How do 3D movies create the illusion of a third dimension? Basically, they imitate how most people's eyes work. You can start to understand this process by doing the following simple experiment. With both eyes open, look at a nearby object, such as a desk or a chair. Now cover one eye with your hand so you can still see the object. Next, cover the other eye with your hand. You'll still see the object, but from a slightly different perspective. Both eyes see the same object, but because our eyes are spaced slightly apart, each eye sees it from a slightly different position. Our brains receive the images from each eye and fuse them into a single image, which allows us to perceive depth. In other words, to know how far away things are. Movies in 3D take advantage of the way our brains work to trick our eyes. When filmmakers create 3D films, they use two camera lenses placed side by side that record the action like a pair of high-tech human eyes. Both images are then projected onto the screen, and the 3D glasses filter the two images so that one image enters the left eye and the other image enters the right. As usual, our brains work to combine these two images, and the result is a 3D illusion. Today, there are many different types of 3D glasses. Two of the most common types of 3D glasses are red and blue glasses and polarized glasses. Each uses a different method to enable us to see the visual effect of a third dimension created on film. Which type of 3D glasses is needed to view a film depends on the kind of light filters that were used when the film was made. Red and blue 3D glasses have been in use for many decades. They became popular during the 1950s when 3D movies were a film fad. In these movies, filmmakers shot footage for the left eye using a red filter, which produced a red image. Film footage for the right eye was shot with a blue filter, which created a blue image. Then, in the movie theater, two projectors superimposed the blue and red images on the screen. Viewers wore 3D glasses with red and blue filters for the lenses. The red filter allowed only the blue images to reach the right eye, and the blue filter allowed only the red images to reach the left eye. Viewers' brains did the rest of the work, fusing the two images together. And to everyone's delight, Godzilla and other imaginary creatures roared to life in 3 dimensions. However, because the red and blue method uses color to separate images, the range of colors possible in these 3D films is limited. The modern method of using polarized filters on cameras and glasses has brought a vibrant rainbow of color to 3D films. In this method, the two camera lenses have polarizing filters. A polarizing filter blocks all light waves except for the ones going in a certain direction. One filter polarizes images on a horizontal plane for the left eye, and the other filter polarizes images on a vertical plane for the right eye. As in the red and blue method, two movies are made at the same time. One is intended for the viewer's left eye and the other for the viewer's right eyes. Also similar to the red and blue method, in the movie theater, two projectors show the two reels of footage at the same time. As the movie reels are rolling, two different polarized images are layered on top of each other. The 3D glasses separate the polarized images, sending one image to the left eye and one to the right. Once again, viewers' brains jump into action, turning the two images into a single three-dimensional world, flickering in full color on a flat screen. What's next in the technology of three-dimensional viewing? Researchers are already experimenting with new methods that do not require viewers to wear glasses. But what fun would it be to watch a 3D movie without geeky-looking glasses?